Okay. So we need to put this into the standard form of a conic. And that always involves completing the square. Okay? So we want to gather our x terms together. And we want to allow for completing the square. Gather our y terms together. Allow for completing the square on that. And let's put the 8 on the other side. The key in doing these problems is to never change the equation. In other words, always make sure you have the same equation you started with. Okay? How do you complete the square on the left?
You divide by 2 and then square that.
Okay? So this becomes what?
X squared plus 8x plus 16.
Alright, now the fact that I added 16 to the left side of the equation means I need to add 16 to the right side of the equation. Okay?
Mm-hmm.
How do I complete the square on the right?
Divide by 2 and then square, which is plus 1.
I have to add 1 to the right also.
Mm-hmm.
Now, the fact that I completed the square allows me to write the left as what? In other words, every time you have to complete the square, it's always because you can write it in a different way. Well, what is x squared plus 8x plus 16?
X plus 4.
Okay. And what is y, this one here?
Y minus 1.
Correct. And now,
25, right?
yeah, now I have it in the format of a conic. What kind of conic?
Okay.
What kind of conic is this?
I have no clue.
It's a circle.
It is.
Uh-huh.
How do we know?
Well, because here's the standard equation of a circle. X minus some constant plus y minus some constant equals r squared. H and K are the center of the circle. R is the radius of the circle. So,
Okay.
in our situation, what is H?
4.
No, it's X minus H.
Well, no, if it's just H, wouldn't it just be 4?
Be negative 4.
Oh,
You
yeah.
see why?
Yeah.
Because if H is negative 4, then you have X plus 4, which is what we started with.
Yep.
What is K?
K is positive 1.
Okay. So the center of the circle is at minus 4 comma 1. What's the radius of the circle?
5.
That's the only 2 pieces of information you need to know about a circle to know everything about it. In other words, if you know its center and you know its radius, there's nothing else to know about that circle.
Okay.
Okay?
So,
The key is to remember the general equation for a circle. What else you got?
hang on. Let me write that down.
I'm guessing that you're going to have an ellipse also.
Probably. Write the general form. Write the general quadratic equation. Y squared minus 8x minus 4x plus 28 equals 0. In standard form, determine the vertex, focus, and directrix of the parabola.
Why do we know this is a parabola?
Because they told us it's a parabola?
No, not really. It's because there's a y squared. Is this 8x minus 4x? Did I have that right?
Yeah.
Really?
Yeah.
So it's y squared minus 12x plus 28 equals 0.
I mean, that's how they wrote it, but I feel like they missed a squared.
No,
But
not necessarily. If one of the variables is squared and the other one is not, then it's a parabola. It's either a parabola like this, it's a parabola like that, or it could be a sideways parabola like that. So there's 4 possible configurations. Okay. We need to put it into the standard format for a parabola. Well, the standard format for a vertical parabola is always y equal x squared, right? You're familiar with that?
mm-hmm.
Well, notice that this is y squared and 1x, not x squared. That means this is a format of that, which is a sideways parabola. It's one of those two. Okay, so what is the standard format for a sideways parabola?
Y or x minus h for a sideways parabola?
Yeah, for a side, in other words, if I was talking about a vertical, a parabola like that, it would be y equal a times x minus h squared plus k. But that's a vertical parabola. If I want a sideways parabola, I just switch the variables. Like that.
Okay.
Can you put this equation, in other words, that equation right there, into this format?
No?
Well, actually you can. Let's put the x on the other side. In other words, we have y squared plus 28 equals 12x. Notice that we're getting closer to the format.
Okay.
Okay. Now we need to complete the square. In other words, if we're trying to put that equation into that format, well, the first thing to do would be to divide everything by 12, right?
Mm-hmm.
So we have x equals y squared divided by 12 plus 28 divided by 12. Now, that's relatively close to that format right there. What do you think A is?
There is no A? Or no. No, there is no A.
It's 112.
Oh.
what would k be?
Mm.
0. And the only reason I know that is because there's no y term. There's a y squared term, but there's no y term. Notice that this equation is exactly the same as that equation. I've changed nothing, and that is the key. You don't ever want to change anything. When you're working your way through these equations, whether they're conics or any other kind of equation, the most important thing is that you can't change it. You can do whatever you want to the left side as long as you do it to the right, but you better end up with the same equation. Now, is this equation the same as that equation? And yes, it is. I've done nothing but divide both sides by 12. Okay? So, what we now have is x equals y squared over 12 plus 28 over 12. Well, notice that that's our general format right there. A is 1/12, k is 0, and h is 28 divided by 12. In other words, the moment, I can erase that, the moment I put it into the general format, I know what A is. A is that. A is this. K has to be 0 because it's y minus k squared. And h is that. So, because it's x equal y squared, it's this kind of a parabola. The fact that A is less than 1 means it is vertically flattened, well, horizontally flattened. So it's more like that. And also, it's adjusted by 2 1/3. Yeah, that's all you need to know. In other words, what you really need to know about these conic equations, what was the question on this?
Determine the vertex, focus, and directrix of the parabola.
All right, what's the vertex?
0, comma,
Well,
28,
the x coordinate is 2 1/3. Let's see. Yeah, 2 4/12. The y coordinate is 0 because there's no k. In other words, this should be our graph. And this point right here is 2 1/3, comma 0. Okay? Now, it's always good to be able to check these. In other words, does this picture that we came up with and this equation of the parabola fit the original equation? Well, in other words, when x is 2 1/3 is y 0. Well, we could go back to the original equation, but this is certainly, unless there was a mistake here, y squared minus 12x plus 28 equals 0 is the proper equation. And if y is 2 1/3, that's 7/3 squared minus 12 times that plus 28 equals 0. And that is not true. In other words, we have 49, well, maybe it is, 49/9 plus 28 equals 0. Well, that's not true. We did something wrong. First of all, let's go back and examine the original equation. Can you check that and make sure that we got that right? That doesn't seem right to me.
Y squared minus 8x minus 4x plus 28.
Okay. So, here's the equations of a parabola. In other words, go back to your Algebra 1. Whenever you have x squared and y, it's that kind of parabola. If there's a negative sign, it's that kind of parabola. Okay?
Okay.
If you have x equal y squared, it's this kind of parabola. If it's minus y squared, it's that kind of parabola. So you can tell whether it's a horizontal or vertical parabola based on which variable is squared. Well, in this problem, it's the y squared. In other words, our equation is right there. Now, all we have to do is really turn that equation into this equation. Now, I need to ask you something first, and that is because different school systems use different general equations of a parabola. Some use that one. Notice that this P is the distance to the focus. Is this what you use or not?
No.
Yes?
No.
No. All right. So what you use must be that one. Or there's an A in front of that.
That's what we use, yeah.
This one here. And the reason some school systems use this one is because P is the distance to the focus. Well, there's not a whole lot of difference between these two equations. The thing is that A has to equal 1 over 4P. So if you're going to use the second equation, then you figure out what A is, and then you can calculate what P is. P is the distance to the focus. Now, let's see where we went wrong. No, let's erase this. No, that was y squared. All right, the first thing we recognize when we look at this is that there's a y squared and there's only an x. That only means parabola. In other words, there's all kinds of equations they could give you. You've had all 4 conic sections, is that correct? Parabola, circle, ellipse, and hyperbola?
Yep.
All right. That is the general equation for a vertical parabola, correct?
Yes.
This is the general equation for a horizontal parabola. Yes?
Yes.
What's a circle?
What is a circle?
Yeah, what's the general equation for a circle?
No clue.
Notice that the circle is going to have an x squared and a y squared to it. So if you get an equation in standard format and it only has a y and an x squared, you know it's a parabola. If it only has a y squared and an x, you know it's a parabola. But if it has an x squared and a y squared, it's a circle. And an ellipse is very, very similar to a circle, only it's got that.
Hello?
Can you hear me?
Yeah.
Okay. And finally, hyperbola. You've had that?
Yep.
The only difference between a hyperbola and an ellipse is the sign. It's negative. You still have a squared plus b squared, or that's the primary difference between an ellipse and a hyperbola. Now, the equation that I wrote is that kind of an ellipse. It's a horizontal ellipse. And the equation I wrote was a horizontal hyperbola. If the A comes under the Y and the B comes under the X, it's a vertical ellipse. If the negative sign comes in front of the X and the positive sign comes in front of the Y, it's a vertical hyperbola, like that. Okay, so being able to recognize what your conic section is based on the formula or the equation that they give you, and it looks like they're giving you the equations in standard format. In other words, they're not going to look like this. They're going to look like some number of x squared, some number of x, some number of y squared, some number of k equals some number. But the most important thing you can know is the general equation of each of these. Now, the general equation that we got was y squared equals 12x minus 28. Well, we can factor that pretty easily. We can factor a 4 out. So that becomes y squared equals 4 times 3x minus 7. So this right here tells us it's a parabola hold on. I'm going to factor out the entire 12 here. It's 12 times x minus 28 over 12. Once we have it in that format right there, we know everything there is to know. K is 0, H is 28 over 12, and A is 12. The key being not to change anything. In other words, the equation that I have circled is the same as what we started with. It's always the key. So make sure you do not change the equation. Well, I have it in standard format now. What is the vertex?
The vertex.
There's the H coordinate of the vertex. What's the K? What's the K coordinate?
0.
Yeah. And because this number is positive, I know it opens to the right. So it has to be some sort of a parabola that looks like that. Okay? And the coordinates of it are going to be 28 twelfths and 0. In other words, the way I've drawn it is correct as long as that's 28 twelfths. Now, does that parabola fit our equation? Well, when x is 28 twelfths, we have 0. And that's exactly what we want, is y to be 0 when x is 28 twelfths. As x goes positive, y squared is both positive and negative. In other words, if we solve that for y, we get plus or minus. So that's the vertex. Now, the focus is A divided by 4p. In other words, some school systems use this as the standard. Excuse me. 4p always goes in front of the variable that is not being squared. That's the general formula in a lot of school systems. Okay? Your general formula is this. So we have an A of 12. So P, in other words, A is equal to 1 over 4P, which means P is equal to 1 over 4A. P is the distance to the focus. Well, in our case, A is 12, so P is 1/48.
Okay.
And what that means is that P is 1/48 away from the vertex. The vertex is at 2 1/3, and P is 1/48 to the right of that. And the directrix is always the equivalent distance on the other side of the vertex. In other words, whenever you come up with P, and we came up with a P of 1/48, that means the directrix is 1/48 to the left of the vertex. It's always outside the parabola. It's always measured along the major transversal, which is horizontal here. And it's always the same distance from the origin as the vertex is, or as the focus is. In other words, the focus is 1/48 to the right of the vertex. Well, that means the directrix is 1/48 to the left of the vertex.
Oh, okay.
So it seems to me like the equation of the directrix is 2 16/48 minus 1/48, so 2 15/48. That is the equation of the directrix, which actually puts it right there. All right, conic sections are a lot. Certainly a lot to do in a half an hour. I would say that to do a proper analysis of conic sections, you're going to need 2 hours because you have parabolas. Circles are very easy. You can do those in 10 minutes. But in addition to parabolas, you have ellipses and hyperbolas. And you have vertical ellipses and horizontal ellipses, and you have vertical and horizontal hyperbolas. So there's a lot there. And figuring out the focus and the major transverse vertices is tough on all of them. So there's no way we're going to cover it in 30 minutes.
Okay.
Okay. Just as a warning to you. In other words, 30 minutes was not enough to cover this material. And I don't know how long you're going to be on conic sections. The most important thing you can do to remember conic sections is to know the standard formula. So let me just give you a couple and see if you know the standard formula. What kind of a conic section is this?
Hyperbola.
That is a hyperbola. Why? Because of the negative sign. It's a horizontal hyperbola because the negative sign is in front of the y. In other words, if I had y minus k squared over a squared minus x minus h squared over b squared equal 1, that would be a what I call a vertical hyperbola, like that. Okay? So all hyperbolas have a negative sign. It's just a question of whether the negative sign is in front of the y or the x. If it's in front of the y, it's vertical. If it's in front of the x, it's horizontal. Okay?
Okay.
Very similar to ellipses. Let's talk about ellipses for a moment. Ellipses always have a plus sign. So that's the way you can tell the difference between an ellipse and a hyperbola. And if A is always greater than B, so if the A is under the x, it's a horizontal ellipse. If the A is under the y, it's a vertical ellipse. In other words, I could also have x minus h squared over b squared plus y minus k squared over a squared equals 1. Notice the difference between these two. With ellipses, A is always greater than B. Not so with hyperbolas. Only with ellipses is A always greater than B. So if you have that kind of an equation, with A greater than B, you have a horizontal ellipse. If you have this kind of an equation, where A is greater than B, meaning A is under the y squared term, then you have a vertical ellipse. And before I leave you real quick, if I have this, that is a vertical parabola. It's either that or that, because I have y and I have an x squared. If I have this, it is a horizontal parabola, depending on the sign of A. And why? Because I basically have x equal y squared. Always remember that that's not where you started. You always started with y equal x squared, right? In Algebra 1.
Yeah.
In other words, if you have y equal x squared, it's what you're used to, a function. If you have x equal y squared, it's not actually a function. It's a relation, but it's not a function. Notice that this does not pass the vertical line test. So the only thing you need to know about parabolas is which variable is being squared to determine whether it's horizontal or vertical. And then with ellipses and hyperbolas, you need to pay attention to more than that. But I would say that the most important thing you can study is the general format for all your conic sections. And by that, I mean the general format of the vertical, the horizontal also. Because you not only have parabolas, ellipses, and hyperbolas, but you have horizontal parabolas, horizontal ellipses, and horizontal hyperbolas. In other words, each of these three conic sections can be oriented vertically or horizontally. And you have to know from the equation that they give you in standard format which it is. In other words, let's just, one last thing here. What kind of an equation is that? What kind of conic section is that?
Well,
You have x squared and you have plus y squared.
Oh, that's not a semicircle, it's a parabola.
An ellipse.
Ellipse.
And I don't know yet whether it's horizontal or vertical. I have to put it in the general equation of an ellipse to tell whether A is bigger than B. If the value under the y is bigger than the value under the x, it's a vertical ellipse. If it's vice versa, it's a horizontal ellipse. And with this particular problem, I would have to complete the square. And then divide everything by 12 to get 1 on the right side. And then I would know which one was bigger, A or B. If I have something like this, the fact that there's a negative sign there means I have a hyperbola. Not only do I have a hyperbola, but I have a horizontal hyperbola, one that's going to look like that. If it's y squared minus x squared, it is a vertical hyperbola, one that looks like that. All right. Kind of wish we had more time that we could do some more, just because conics is not something you can cover in a half an hour. Okay?
Yeah.
All right. I'll let you go. Wednesday at 4:30?
Yep.
Okay, I'll talk to you then.
Okay, bye.